So now that we have seen the different basic math for statistics that might be useful for you to understand the statistical formula that we will use in this lecture, let's move to what we call variable in statistics, because you should know that when you have your data, you have two parameters. You have the variable and you have the observation. And I'm measuring the value of my variable on each of my observation, and I will take concrete example in a couple of minutes. So what is a variable and what are the different type of variable? So here, first of all, you have the quantitative variable. When we talk about variable, it's something which varies, right? But then there are two core type of variable in statistics. So a variable X is said to be quantitative if it can be assigned a numerical value. And here I want to emphasize on the fact that a numerical value is not a code. So one may pay attention on the fact that there are some variables that are qualitative, especially the categorical type of qualitative variable like the gender, for instance, which can be assigned numerical code but should not be qualified as quantitative. So here I will further explain what we mean by numerical value and what we mean by a code. So we have two types of quantitative variable. We have discrete variable and we have continuous variable. So a discrete variable, it means that the value of the variable are distinct and separate or can be counted. For instance, the number of MPP students per year. So what I'm doing here is that I'm just trying to have the folder of each of the total number of MPP students over the past 20 years, for instance. So in 2017, I know there were 136 students. In 2016, there were 120 students. So the year of my observation, and the variable that I'm measuring here is the number of MPP students in each batch over the past year. So variable, so you should know there is a word vary, so there is variation, right? So this number is not the same over the past 20 years, and that's the number. Those numbers are my observation. So 136 in 2017, 132 in 2016, and so on and so forth. I'm also having the other example that I took here is the number of housemates of each MPP student. So say for instance that I'm coming into the class tomorrow and I'm asking you guys, with how many people do you live in your house? And then the first student will say, I'm living with one person. Another one will say, oh no, I have enough money to rent my own apartment or my own studio and I'm living with 0 students. Another one will say, no, I have 8 housemates, which I don't think is possible. And another one will say, I have 4 housemates or 3 housemates. So here again, the variable is the number of housemates and the observation are MPP students. So in the data framework, in column you have number of housemates, and in each line you have each MPP student answering this question. So here this is an example of a variable which is said to be discrete because it can take distinct value. The number of housemates cannot be 0.3 or 0.2, right? These are like they can be counted, they are distinct, they are separate. And another, for those who are agricultural lover, for instance, if I want to know the number of apples produced by each region of the Benelux area, so as observation, so in my row I will have the total number of region in the Benelux area. Benelux standing here by Belgium, Netherlands and Luxembourg. So say for instance that this area has 100 regions. So in each of those regions, so in each of my row, I'm going to search the information on how many apples, what is the total number of apples that are produced by this region, say in 2017. So for instance, I can say, okay, the Limburg region in the Netherlands area has produced 1 million apples. And also, for instance, I can go and continue and say, okay, the another region can be potentially the Groningen region, for instance, has produced 2 million apples, and so on and so forth. And those numbers, as you can see, they can count. You can count the number of apples, and the value are separate and distinct. You can count 1 apple, 2 apple, 3 apple. and so on and so forth. So these are the first main type of quantitative variable. You also have the continuous variable that will be used a lot. So these are the variables that may take any value within a finite or infinite interval. So it means it's not restricted to 1 to 3. Okay, so it can vary across a specific interval. And an example is, for instance, the weight, the height, or the body mass index of MPP students. So I can just come to the class and say, okay, what is your weight? And then someone will say, I have 79.9 kilo, I have 100 kilo, I have 40.3 kilo. So here you can see there is an interval. So the weight of MPP student might vary between 50 kilo and 150 kilo, for instance, and we will therefore say the weight of MPP student is a variable which is continuous. The same goes for the height or the body mass index. And another example which is closely linked to your data is the income, right? So the income is also a continuous variable because it can take any value within a specific interval. For instance, in the Netherlands, the income of people, because the minimum income say is 1,000 euro, so the income vary between 1,000 and 25,000 euro per month. So this is a continuous variable. It can take any value between a specific interval. So now let's take this little exercise. So I want you guys to go back home after those explanations to depict what is the nature of this variable. So the production of milk in the Netherlands per day, the number of minutes it takes to each MPP student to get to UNU so at bus track 24th Street every day, the number of suitcases lost by European airline company in 2016. So just go back home with those explanations here above, try and tell me what are the nature of those variables. So now let's move to qualitative variable. So what is a qualitative variable? A variable is said to be qualitative if it cannot be assigned a numerical value. So it cannot be discrete, it's neither discrete nor continuous. However, as we raised above, most of the qualitative variables could be codified with numerical value, but that doesn't mean they are quantitative, right? So for instance here, the age category. For instance, let's say I'm trying to measure what is the age category of people that participated to a football game, to the last football game in Maastricht. Say there were a football game between the School of Business and Economics and UNU Merit, and at the end of the game I'm standing at the outside the door and I'm trying to measure the age category. So here, for instance, you have 3 different age categories: infant, adolescent, or adult. So you cannot be infant and adolescent at the first time, right? So you are either an infant or an adolescent. So those are the 3 categories, for instance. And then you have the origin of a car. For instance, I can ask you guys, do you have a car, and what is the origin of your car? And for people having a car, they have 2 categories, or they have 2 set of answers they can give. Either the car is foreign or either the car is a domestic one. So we also have specific type of qualitative variable. So first, the variable can be categorical. Categorical means sometimes you also see the term nominal, so you should not be confused. It means the same. So here you have categorical. It means that there is no intrinsic ordering to the category. For instance, the gender. So you have 2 categories. Either you are a male or a female, right? Or for instance, the breed of your dog. Either your dog is a collie, a shepherd, or a terrier. So you should mention there is no intrinsic ordering. That's the key difference between categorical and ordinal. In categorical variable, you don't have an order, right? So you cannot say, for instance, that 2 is greater than 1, like a female is greater than a male. There is no scale, there is no ordering of the category. Rather, in ordinal variable, you have an intrinsic ordering. So you can attach or you can rank the value or the scale of your variable. right? So I also forgot to say that most of the time you also see the term dichotomous variable. It means categorical variable, but only when you have two categories. So here, for instance, we will say that gender is a dichotomous variable, but it's not the case for the breed, which has three categories. So dichotomous is dico, so you should remember it's about two when you have two categories. So an ordinal variable is, these are the kind of variable which that you can rank, so you can attach a rating scale. For instance, at the end of the introduction to data science, you'll be giving an evaluation questionnaire when you have to give an overall appreciation of your respective tutors. So then you have to answer the question, how much do you like your tutor this year, or how much do you think your tutor is knowledgeable, or how much do you appreciate their performance? And then you have to answer you have to answer, and by choosing the between those categories. So the first one is you don't appreciate them very much, you think they are not performant at all, so least positive. The second category that you have is you're neutral. The third one is you think is positive. The fourth one, you just say yes a lot, you appreciate them a lot. And then you have to choose, and you will clearly see that some tutor that got a 1 is worse off as compared to the one having a 4. So 4 is greater than 1. 4 is greater than 1, as 3 is greater than 1. So you can actually assign a scale, right? So not very much is the lowest grade per se, just to say it like that way, whereas 4 is the upper grade, so the highest grade that a tutor can have.